Hello and welcome to another video. In this video we're going to be doing single number 3, and in this one you're given an integer nums and two elements appear exactly once and everything else appears twice. And you want to find the two elements that appear once and you can return them in any order, and you must write an algorithm that runs in linear time. So obviously without these conditions it's very easy. We can just use a hash map or a sort, but that would be an easy problem. So to start out, you're going to need to know a couple properties of XOR, and I would suggest solving single number 1 to kind of get what you need to start with. So we can go over that really quickly. So basically there's a couple properties of XOR that you need to know. One is an element XORed with itself equals 0. And the second one is if you have multiple elements XORed with each other, the order doesn't matter. So like all of these are equivalent. It doesn't matter at all. It's basically like addition, because basically what XOR does is for every bit, you just count the number of times it appears, and essentially you're just getting the number of times each bit appears and you mod it by 2, and that's basically an XOR. So that's what it is. And so now that you know that, let's say this problem is simplified to only one number appears once and everything else appears twice. That's a easy problem. Knowing these two things, you can just XOR every single element. So let's say we have elements like A, like let's just say we have like A, B, A, C, A, B, C. Like these are elements, right? These are numbers. What's going to happen is, actually, screw this up a little bit. So let's say we have this. So let's screw this up. So let's say we have an element here. Right, so these are our elements. So when you XOR them in any order, the A's will cancel because an element XOR with itself is 0 and the order doesn't matter. The B's will cancel and the C's will cancel. And so you'll have D left over. So if you have one element, it's pretty simple. You can just XOR everything and then your one element will be left by itself. But the problem is we have 2. So what happens if we have 2? So if we have the same thing, if we have like, let's say we have A twice, we have B twice, the order doesn't matter, so I'll just write it like this. And then we have like this. What's going to happen if we XOR all of this? So the result of this will be this, right? D XOR E. Now we know for sure that this does not equal 0 because our elements have to be different, right? So XOR of X and Y, so X XOR Y cannot equal 0 if X does not equal Y. It's not possible, because the only time an XOR of two numbers is 0 is if they're the same. So what will this XOR give us? Well, let's just take a look at some numbers. So let's just say we have some numbers. Let's make a small array maybe. So let's just say our numbers are like 1, 0, or no. Yeah, so let's do like 1, 0, 1, 0, 1, 0 as our first number. And then maybe let's copy this thing. Let's get rid of this guy. And then our second number can maybe be like this, just to keep it easy. It doesn't really matter. And what's the result going to be here? So if we XOR these two, so this will turn into a 0. This will stay 1. This will turn into a 0. This will stay 1. This will turn into a 0, and like this. So the result, all the bits that are 1, and you're guaranteed to have at least 1, is all the locations where these bits are different, right? Because if they're the same, they will just be 0, because 0 XOR 0 is 0, 1 XOR 1 is 1. So we're going to get this result. So this is like the two numbers XORed with each other, A XOR B. Now, this is kind of useless because from this, we can't really figure out which is which in like O of 1 or something, because there's multiple numbers that can XOR to this. For example, let's say we have like 2 XOR 3. So 2 XOR 3 gives you 1. But we can also have 1 XOR 0 will give us 1. Or some other thing, right? Like this number XOR this number. So this is 7 XOR 5. That will also give us 1. And so there's a bunch of combinations that will give you. There's like infinite combinations that will give you this. Well, not infinite because it's like a 32-bit number. But you can't just figure out like what numbers they are just from having the XOR. But what you do know for sure is each one of these bits is unique to A or B, right? So because if you look, this bit is only in B. This bit is only in B. this bit is only in B, right? If this is A and B. And this is always going to happen like that. Now, in this case, all these bits are only in B, but if I reverse some stuff, all of these bits are going to be in only one of these. So what we can actually do from here is we can say, okay, all we need is actually, so there is a way to get like one of these bits in O of 1, but I don't think it's necessary. I think it's overcomplicating things. All we need is one of these bits and to know the location. So all we need is to just make a number with one of these bits. So we can just loop through this and check for the bits, and the first non-zero bit we'll find, we'll use that number. So in this case, we'll have the number 1. So we'll make a new number with just the 1, and then the rest will be zeros. We can just take the rightmost one just by looping through it and just checking, and I'll show you how in the code. So this is our number now. So it'll be like this. Obviously the indices don't matter, this is just our number. So this number is 0, 1, 0, 1, 0, 1, and this number is 0, 0, 0, 0, 0, 1. The indices, can just ignore those. So now we know that like one of our numbers has a 1 and one of them does not. Let's say B has this. So now what we can do is pretty easy. We can go back through all our numbers in this nums. So let's just say these, so this is A and B, and let's say our numbers were like A, B, and then 2 combinations of C, 2 combinations of D, 2 combinations of E, and so on. So what we can actually do now is we can loop through this again, and we could say, okay, for every number, if that number ANDed with this guy is non-zero, that means that number, or you could figure out where, if you don't want to AND it, I think more performant would just be figuring out like the index of where this occurs. So you could just figure out the index where this occurs. So let's say this occurs at, you know, the 1 bit. So we could figure out, okay, for every number, if that number has a 1 here, then there's 2 possibilities, right? Either that number is B, or that number is one of the duplicates. But it can't be A, right? Because, like I said, if you just take 1 bit out of this XOR, it's going to be in either A or B. So in this case, it was in B, you know, maybe it's in A, but basically it's either going to be in one of these 2, not both, or it'll be in a duplicate. And if it's in a duplicate, we're going to take it twice. And if it's in one of these, we're only going to take one of these numbers. So essentially what we'll have is, like, let's say the 1 is in the C, let's say it's in the E, and let's say it's in the B. So then what we're going to do is basically B XOR C, XOR C, XOR E, XOR E. And now that, we're only using one of the numbers that appears once. And possibly some duplicates, whatever amount, but all the duplicates will appear twice. Because if 1 is in this C, it's also in this C, and so on, right? So what's going to happen here is these will cancel, and now we will get one of our numbers. And once we get one of our numbers, we can actually get the result because we have A XOR B. So if we have A XOR B, A XOR B, and we have B now, so we can XOR it again with B, and that will give us our second number, because a number XORed with itself gives you 0, so now this cancels, and now we have A. So to sum it up again, first we're going to XOR our entire array. That will give us not array, we'll XOR all our numbers. That will give us a number where every 1 bit is only in one of the results. It's basically every 1 bit means it's in one of the numbers and not in the other. There has to be at least 1 because the numbers are different. All we need is one of these bits, figuring out its location. Then we go through all the numbers again, and every number that has this 1 bit set will XOR all those. That will give us one of our 2 numbers in the result, and then we could take this guy and XOR it with one of our 2 numbers to get the other one. And that's what we'll return. So I think actually it's probably better to, I don't think it matters. I mean, it's still, like, you can just take this number. I don't think it matters. Like, do I want to take the index of this number or just this number? I'll just take this number. So we're going to take this number of, like, one of the bits being set, the rightmost bit being set, and XOR it with all of these and make sure, or not XOR. So the way to check if this bit is in all of these is you just do any one of these and this. And then, you know, one of those numbers will be, you know, whatever the bits of those numbers, they don't matter as long as this bit is a 1. The rest don't matter because zeros ANDed with the rest of it will just be 0. But as long as this bit is set, that means these will be ANDed to a non-zero value. And that's what we'll check for. Okay, so let's code it now. So first we'll have our cumulative XOR, we'll set it equal to 0. We're going to go through every number in nums, and we're going to XOR with it. So now this XOR is this guy over here, right? A XOR B, because everything else is canceled out. Now we just need one of the bits in here, and we know it's a 32-bit integer, I think, so we can just loop from 0 to 32 and just try every single location until we get one. So we can say like int bit equals 0 for now, and we could say like for int I equals 0, I is less than 32. And so the way to check if a bit is set is you can just take a 1 and you can left shift it sometimes. So like let's say we have like this number. So like this, let's just say we have this number. What we can basically do here is we can say, okay, let's take a 1 and let's shift it sometime and let's AND it with that number. So we'll start with shifting it 0 times, and when we AND these two, like I said, this 1, if we're only gonna have a 1, everything else will be 0, so this whole thing will be zeros. And then when you AND it, all of this will be zeros, and then if the bit matches, like if there's a 1 here and a 1 here, then you'll get a non-zero number. Similarly, if I take my 1 and I shift it, so this will be shifting it 0 times. If you shift it 1, 2, 3, 4, 5, whatever. Let's say I shift it over here, all of this will be 0, all of this will be 0, and you just check like, is this bit set? And if it is, that's all I need. So we're just looking for one of the bits being set. We start over here, we just keep looping through our number until we get one. So if 1 shifted left I times and our XOR is non-zero, that means we have a bit that's set and we can use it. So if that's the case, we'll just say our bit can be this whole thing. Or we could do this, I guess. Either one's fine. Yeah, so actually I think we can just do this. I believe this should work. I don't know if this will actually give us a negative number. I don't think so, but we'll find out. I don't think so, but yeah, we'll see. Or we could just take the number itself. The number itself for sure won't be, so I guess let's just take the number itself just to be safe. So we can take this whole thing. I think it should give us, actually let's just try this and see what happens. So this will basically be the one bit, the first bit we found that was set. And then we can break. And we're guaranteed to find something in here because at least one of these would be set. So now basically what we have here is we have the rightmost bit that's set in our XOR. Now we're going to loop through this guy again. And we're going to take an x value this time. So we'll say int x equals 0. So this will be like our first number, and we can call it first. And if num and the bit does not equal 0, that means this bit is set in the number, so this bit can't be the second number. It can either be a duplicate or the first number. Oh, or one of the two numbers. So it has to be one of the two numbers, it can't be both, or a duplicate, which is fine. And so this is not 0, then we can XOR with our number here. Like this. So now first will be set at the end, because essentially we're going to take one of the two numbers and XOR it with some duplicates, but every duplicate we XOR with will be XOR twice. And now we can get our second number by doing XOR with first. And now we just return the array of first, second. So hopefully that makes sense. The trick that XORing two numbers is 0, if you've done the bit manipulation, that one's pretty easy. The other one, figuring out like how I take two numbers XORed with each other and just get one of them, is a little bit trickier. But once you recognize like all these bits are different for the numbers, all I need is one, and I can just compare it with all my numbers I'm XORing with, then it's not that bad. So I think this is like definitely not too hard of a bit manipulation problem once you understand the little tricks. Yeah. Okay. Let's see what we get. Interesting. I might need like another this maybe. Yeah, okay. So yeah, I guess it does the equal, not equal before the and. Okay, there we go. Okay, nice. So hopefully that makes sense. If you have any questions, as always, write in the comments. I think this is kind of a cool problem because you learn a lot of tricks. And XOR is probably the most common bit manipulation that you use. So learning all of these, like, A XOR is 0, and the order doesn't matter. I forgot what the actual like mathematical term for it is. But yeah, like learning all these things is going to be good for harder problems because you're definitely going to use it, and it's the most common bit operation on LeetCode by far. So hopefully it was helpful. So let's go through the time. So essentially we're going through all the numbers once here. Then we're going through all the numbers once again. This is only 32, so constant time. So this space constant. We just have numbers. We don't have arrays. I just drew in an array in the picture to make it easier to see. Yeah. So hopefully this is helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.